Welcome back to Jackson Square. Today we're looking at TEAC 6.4D, which says, I can give examples of rates as the comparison by division of two quantities having different attributes, including rates as quotients. So today we're looking at rates and unit rates. First, a rate is a ratio that compares two quantities with different kinds of units, okay? So we learned that a ratio was a comparison of two things, boys to girls, sneakers to sandals, all fruit to bananas. So today we're learning that a rate is a ratio that compares two quantities with different units. So today we're going to be looking at money to pounds, words per minute, gallons per miles per hour, things like that. They have different units. So an example would be 100 words to 2 minutes, words and minutes. Okay, before we were talking like boys and girls, so children to children, or fruit to fruit, or emoji happy to sad, faces to faces. So now we're looking at things that have different units. Those are a rate. When a rate is simplified so that it has a denominator of 1, so here we're going to put denominator of 1, it is called a unit rate, okay? Unit, when we talk about unit, we're talking about 1. Unit rate is 1. So in a fractional form, our denominator would be 1. When a rate is simplified so that it has a denominator of 1, it is called a unit rate, okay? It is called a unit rate. We have unit rate many times when we're talking about how much the bananas are per pound. That's 39 cents per 1 pound. That's a unit rate. When you're paying $2.12 per gallon, that's unit rate. When we're talking about how much you pay for electricity per kilowatt hour, that's unit rate. So notice every time you hear me saying per something, okay? So unit rate also, you're going to hear the per. That means 1. 1, 1, 1, 1. Unit rate is over 1. Denominator of 1. 1, 1, 1, 1, 1, 1, 1. 1 second, 1 minute, 1 gallon, 1 hour, 1 year, 1 decade, 1 week. 1, 1, 1, 1, 1. Anytime we're talking about one of something, it's unit rate, okay? To find unit rate, write two quantities as a fraction. Divide both the numerator and denominator by the denominator, okay? So the numerator and the denominator are going to be divided by the denominator, and that will create a denominator of 1, okay? A single unit means 1. So again, a single unit means 1. That's supposed to be pointing at the 1. Write unique units of measurement for both, okay? So let's look here in the example box. It says 100 words in 2 minutes. So Ms. Jackson can type 100 words in 2 minutes, but I want to know how many words she can type per minute. So based on the directions, I'm going to divide the numerator by the denominator and the denominator by the denominator. Here our denominator is 2. 2 divided by 2 will give me 1. And 100 divided by 2 will give me 50. So 50 words per minute, okay? There's that per. That is our unit rate. So in 1 minute, Ms. Jackson can type 50 words, okay? So 100 words in 2 minutes, that's a rate, okay? They're comparing two quantities with different units. That's a rate. But then when we find out how much per minute or for 1, that's the unit rate, okay? This is a rate. This is a unit rate. So let's talk about, or let's see how we're going to solve unit rates. Alex can run 24 miles in 3 hours. That's a rate, okay? Miles and hours. We're comparing two units. What is the average speed in miles per hour? Per hour. Okay, so when we talk about things, when we're talking about ratios, rates, unit rates, we're always going to use this thing called an H chart. Why is it called an H chart? Because it looks like an H, duh. So we're going to make a H chart. Okay, that's my H. And we are going to put in the information that we have. So we have 24 miles in 3 hours. Units are so important. I'm going to write on top miles. And then on the bottom, I'm going to write hours. And then I'm going to fill in the numbers they gave me. I have 24 miles for 3 hours. Okay. And I want to know how much per hour. So in 1 hour. So here I'm going to put a 1. So remember, how do I get from this 3 to 1? Remember, we have to divide by the denominator. We're going to divide this by the denominator and this. So divide by 3, divide by 3. 3 divided by 3 would give me 1. And 24 divided by 3 would give me 8. So we want to know the average speed per hour. That would be 8 miles per hour. That line means per. Or if you wanted to write it in word form, or 8 miles per hour. Okay, so again, we made our H chart. I put my units, miles on top, hours on the bottom. 24 went with miles, 3 went with hours. The directions tell us to divide the numerator and the denominator by 3, okay? The denominator number to get it the unit rate. Please make sure you are following and I'm modeling how I want your work to look. Okay, I'm modeling. This is going to help build when we get to ratio tables, when we get to conversion factor, when we get to proportions. So let's start practicing now how to create this H chart. Next, it said you buy 5 pounds for $35. How much does 1 pound cost? So we're going to create our H chart. Something that I need you to know. All teachers don't teach this, but I definitely teach this. So remember, money is always on top. That will always save you from dividing crazy numbers or having crazy numbers in your denominator. Money is always on top. That should be easy to remember, right? Because everybody loves money. So money's always on top. Anytime we're talking about money, money's on top. So we're talking about $35 for 5 pounds. Money's going to go on top. And then pounds, LPB, that's the abbreviation for pounds, will go on the bottom. So for money, we have 35, and for pounds, we have 5. Remember, we're trying to find the unit rate. That means we want our denominator to now have a be 1. So how do I go from 5 to 1? Hopefully you said by dividing by 5. 5 divided by 5 will give me 1. What do I divide the top by? The same thing. Remember, we want to keep balance, just like an equation. Whatever I do to the bottom, I do to the top. So 35 divided by 5 will give me 7. So how much does it cost for 1 pound? It's going to be $7 per pound. And again, if you want to write it in words, $7 per pound. Money is always on top. Okay? So when we're talking about unit rate, there's this thing called the better buy. Okay? So we're always going to be looking at comparing purchasing items for the better buy. The cost of different sizes of orange juice are shown in the table. Which container contains the least per ounce? Okay? So the important part is here, least per ounce. Least. When we are looking at the better buy, we want to pay the least per ounce, per pound, per whatever the unit is. We want to pay the least. So if there are bananas and they are, let's say the non-organic, or 59 cents, 59 cents per pound, and then the organic or 75 cents per pound, I want to pay the cheaper price. I'm going to get the non-organic because they're 59 cents per pound. compared to 75 cents per pound. Okay. Sometimes it could be cents, like tenths or hundreds of a difference. Those things add up. So even if I'm paying 5 cents per unit compared to 6 cents, hey, those little hundreds will add up eventually after time, over time. So comparison and better buy, you always want to get the least amount. Okay. So again, we're going to set up a few and then I'm going to leave you to practice some. And I'm going to grab a pen for this. I am going to write my rate and then set up my unit rate table, my H chart. So there's a 16 ounce, a 32 ounce, a 64 ounce, and a 94 ounce. And here are the costs, okay? The rate. The rate would be, money's on top, I would pay $1.28 for 16 ounces, okay? So you can go down and write all your rates. The money's gonna go on top and the ounces will be on the bottom. Then cost per ounce, I'm going to set up my H chart, and all of your H charts will look the same as well. Money will be on top for all, and ounces will be on the bottom. So the first one, we'll do it together. I would have $1.28 on top, and I have 16 ounces on the bottom. I want this to become 1. Okay, so since I want it to be 1, I'm going to divide by 16. I always divide by the denominator, and I'm going to divide $1.28 by 16 as well. Okay, so you would have to do some side work, but I know that this would come out to be 8 tenths or 8 cents, right? 8 cents per ounce. So I'm paying 8 cents per ounce if I buy the 16 ounce. How much am I paying per ounce for the 32, for the 64, and for the 96? Okay, so what I want you guys to do is pause, practice setting up your H chart, dividing by the denominator, figure out the unit rates for each one of these, and then come back and join me. Welcome back. So hopefully you guys were able to tackle these problems and divide T-bow, top in, bottom out, right? Okay, so we should have the unit rates. The 32 ounce is 6 cents per ounce. The 64 ounce was 4 cents per ounce. And the 96 ounce, we end up getting 35 thousandths per ounce, which you could round up to 4 cents. But which one is the better buy? Which one is the least per ounce? If I was buying and I wanted to pay the least per ounce, I wanted to get the better buy, I would buy the 96 ounce container of juice because I would be paying 3 cents per ounce. That's the cheapest amount, or I would be paying 35 thousandths per ounce, which is still the cheapest compared to all the rest. So that's our better buy. Notice how I set up all of my H charts and I divided by my denominators and I put in my unit rates, and here how I wrote out my rates. Remember, money is always on top. So hopefully you understand rate and unit rate. Let's go practice.